the question here is one of the questions from the current electricity, potential difference, which is voltage, and resistance. The question says, calculate the current in each external resistor. Then B part of it say, calculate the potential difference across AB. Now the question says that we should calculate the current in each external resistor. The external resistor here is this one, this, and this, right? Then from the circuit, we have voltage, which is 10 volt from the battery. Then we have a resistor in the battery, which is 2/3 ohms. Now let's start calculating. But before we calculate and find the total resistance of the whole circuit, we will now find it one after the other. First of all, we'll find the total resistance of these resistors connected in parallel. After finding them, then the circuit will now has resistors in series. It will now has resistors in series. From here to here, combining this one together will now be resistors in series. But now let us find the total of this one in order for them to be resistors in series. Okay. First, now the total resistance here will now be 1/R equals to 1/5 plus 1/10 for this one, which the LCM of 5 and 10 is 10. Then 5 divided 10 is 2. 2 times 1 is 2 plus 10 divided 10, 1. 1 times 1 is 1, which is 2 plus 1 is 3/10. Making this subject of formula, we now do cross multiply. R times 3 up here will be 3R equals to 1 times 10 will be 10. Making our subject of formula, now have R equals to 10/3. That is 10/3 ohms. 10/3 ohms will now be the total resistance here that is connected in parallel. Okay. Now let us now find the total resistance of the whole circuit, which will, because they are now connected in series. So the total now for our series connection will now be R equals to the one in the battery, which is 2/3, plus this one external 1, plus the total one, which we have calculated to be 10/3. And when we sum them up, the LCM, we make this one over 1, okay, for all of them to be in a fractional form. The LCM of the denominators is 3. 3 divided 3 is 1. 1 times 2 is 2, plus 1 divided 3 is 3. 3 times 1 is 3, plus 3 divided 3 is 1. 1 times 10 is 10. And when you add all of them, this plus this plus this, it will give us 15/3. Therefore, the total resistance will now be 15 divided by 3 is 5 ohm. Total resistance here, all of them is 5 ohms. Now let's begin to calculate now. Then let's calculate for the, since all of them are in series now, the current passing through series connection of resistors are the same. So the main current that is passing through all of them when they are in series is what I'm calculating. Now the current now will be V/R, which is our V is 10 here, all over R, the total one, which is 5. So the 10 divided by 5 is 2 ampere. So the main current passing through them is 2 ampere. Therefore, the current passing, now the questions, now starting to calculate for our individual current passing through each resistor. Now the current passing through this one, since it is in series, okay, the current passing through the first one will now be 2 ampere. There's nothing you calculate there. It's the same current that will be passing them through. It's the same current that is passing them since they are in a series. But coming to this, if this current is moving at 2 pass here, coming to this one, it will now be different because the one entering 5 ohm will be different from the one entering 10 ohm because current moving through parallel connection of resistors will be different. Now, let us calculate for each of the current. But before then, we will now calculate voltage across two of them. We will now calculate voltage across this one and this one first before we can now know the individual current that pass through them. Okay. Now let's calculate for the voltage across this 5 and 10. Now the voltage across them, which is V, will now be IR, which is current times the resistance. And our I is 2. Do you understand? Our I is 2, moving in two of them now, times the resistance, which I've calculated both of them, and it gives us 10 over 3 for this one only. Okay, 10 over 3, 10 over 3, which this time this is 20 over 3, and 20 divided by 3 is 6.67 volts. Now let us begin to find for the current across that across this 5 now will be I, which is equal to V over R, which is equal to V across here is 6.67 all over the R, which is 5. The answer will be 1.334 ampere. So the current across here, this one, is 1.334 ampere. Then what of current across here? The current across here will be now be current across 10, and this one the current across 5. Now be V over R, which is our V across here is what? 6.67. 6.67 all over R. Our R should be 10 now because the one we are checking 10. And when we divide, it will now be 0.667 ampere. So we have finished calculating it. The current across 1 ohm is 2. Is what? 2 ampere. Then the current across 5 is 1.334 ampere. Then the current across 10 is 0.667 ampere. That we have finished calculating for the first question. Now we say calculate the potential difference across AB. So the potential difference across this one. Now the potential difference across 1 here will be V equals to IR, that is current times the resistor, which is the current that across there, which is 2. The current that across here, which is 2 ampere, times the resistance of the resistor, which is 1. 2 times 1 is 2. 2 volts. So the voltage across 1 ohm is 2 volts. Answer. This is how to calculate this type of question, right? Make sure you subscribe on my YouTube channel and follow me on Facebook for more interesting questions. Thank you so much for watching, and God bless.